Now, dear students, we will try to now understand that how we can generate a PWM signal on Arduino pin. This PWM signal is sometimes used, or you can check the effect of PWM signal on an LED. So in this video we are going to understand about the PWM and the effect of PWM signal on the LED. As you have seen that we in the previous video we have added the logic analyzer and we have understood that how to use this. In this video we will be trying this logic analyzer tool. We will be using this analyzing tool to analyze our analog signal that is generated by the Arduino Uno. So today we are going to understand number one thing, that is the PWM. So let's say if I the first thing that we will do is to write pin mode, and on the pin mode 9 we are going to say that it's an output, and let's generate the PWM signal using our default technique, that is using the digital write, and let's specify the pin number 9 and give it a value high. Then after some time give a delay, let's say a delay of 25 millisecond, and then again digital write pin number 9, give a value of low, then delay of 50 millisecond. Now let's just save this and let's run the simulation. You can see that LED is on and the logic analyzer is collecting the samples of that signal. So this is one way we have already studied in the while studying the logic analyzer tool, that this is just the shape of PWM that will be generated using this code. So let's just stop this and let me just open the pulse view. And as you know that when we stop the simulation it downloads a file. So let's click over here, let's import change value dump, and this is the file that is downloaded. Let's hit OK, give a down sampling factor of 50. So you can see that this is the PWM signal. We have just studied in the previous video that there is a, let me just zoom this in. We have seen in the previous video that this is a square wave. It's a PWM signal which have a high time, that is the T on, and this is the low time, that is the T off. And if we add on time and off time, that is the period. And if we divide on time by period and multiply by 100, that is the duty cycle. So this is a PWM signal. This we have generated using our very basic technique. But if we want to use the function of the that is provided by the Arduino library, that is analogWrite function, in which the first parameter is the pin number at which we have to generate the analog value. The second is the value that ranges from 0 to 255. If it's a 0, if we pass over here 0, it will be, the LED will be off all time, and if we pass 255 to this value, then the LED will be on all the time. So analogWrite function will generate a PWM signal onto the pin number we will be specifying. As we are going to use the analogWrite function, this analogWrite function will work on only those pins that have this sign. Let me zoom in. That will have this tilde sign. You can see that like PWM, then we have this sign. On the pin number 3, this is available. 5, 6, 9, 10, 11. On these pins 3, 5, 6, 9, 10, 11, only these pins can generate PWM signal using analogWrite function. So let me just generate this, as we have connected to our pin number 9 that has the functionality of generating PWM signal. So I can write over here analogWrite pin number 9, and let me first of all write 255, and let's just save this and let's run the simulation. You will see that LED is on all the time with its full brightness, and if I stop this, you can see that file has downloading. Let's open the pulse view and let's import our file, this one, and let's hit OK, and let's add sampling factor 50. Okay, now you can see that I have said when we write 255, the output will be all time on. You can see over here it's all time on, it's not 0 anytime. The next thing I have told you that if we write 0, then it will be all time off. Let me just run the simulation. You can see that LED is on. LED is off. When we pass 0, LED is off. And let me just stop the simulation, and it have downloaded the file. Let me go there in the pulse view. Let's import the value change dump file. Click on this, click open. Let's write down sampling factor 50, and it's 0 all the time. So now if we write any value between 0 to 255 over here in this, then that will generate a PWM. Let's say if I'm going to write 100, let's save this, let's run the simulation. You see that the LED is on, but it's not full bright, and the Voqui logic analyzer is calculating, taking the samples of the PWM. Let me just now stop this. It have downloaded another file with the third file. Let's open the pulse view. Let's import value change dump, and let's open this. Let's open, change to down sampling factor 50. You can now see that I have generated a PWM signal using the analogWrite function. You can see that it has a square wave with the on time, then it's off, and it's the PWM signal we have just studied in the previous videos. Now this technique is actually used to change the brightness of the LED. So let's say if I change the value to 20, and I can observe the change in brightness of the LED. You can see that it's very dim, and now if I again change it to maximum, that is 255, let's save this, let's run the simulation. You can see it's now in full brightness. So hopefully I am sure that you have understood that how we can generate a PWM signal using the analogWrite function that is provided in the Arduino library. So hopefully you have understood.